Hello, welcome. This is CH Arvind Kumar, Assistant Professor, Department of Computer Science and Engineering, Vagdevi College of Engineering. I am going to explain Network Security and Cryptography Lab. Our first week program is write a program to implement Cipher Cipher algorithm. Cipher Cipher is a simple substitution cipher. In substitution technique, each individual character is going to replace with another character in alphabets. Cipher Cipher was developed by Julius Caesar with shifting of 3 characters. Cipher Cipher is a stream cipher, and this each individual character of plain text is going to replace with another character in alphabet with fixed number of positions. To perform encryption, we are using this particular formula. If we perform encryption, we will get ciphertext. To generate ciphertext, the plain text character is added with key and the result is mod with 26. Coming to decryption, decryption is exactly reverse to encryption. If we perform decryption, we will get plain text. To generate plain text, ciphertext character is subtracted with key and the result is mod with 26. Here we are performing shifting of 3 characters. So A is going to replace it with D because D is third character after A. 1, 2, 3. In the same way, B is going to replace with E because E is third character after B. Like this, each and every character in alphabets is going to replace with third character after it. So these are all our plain text characters and these are all our ciphertext characters for this particular plain text characters. To perform encryption and decryption, first label alphabet with numbers 0 to 25. Encryption is performed by sender. Sender plain text is HELLO. H is represented with 7, E is represented with 4, L is represented with 11, L is represented with 11, O is represented with 14. Now we are going to use key here. Our key is 3 because we are performing shift 3 operation. So we are going to add this key with plain text numbers. If we add key with plain text number 7, we get 10. In the same way, 4 added with 3, the result is 7. 11 added with 3, result is 14. 11 added with 3, result is 14. And 14 is added with 3, result is 17. Now we are converting these numbers into characters. 10 represents K, 7 represents H, 14 represents O, 14 represents O, and 17 represents R. This is our ciphertext. This ciphertext will be forwarded to receiver. Receiver is going to perform decryption. Decryption is exactly reverse to encryption. So receiver got the ciphertext KHOOR and its represented numbers are 10, 7, 14, 14, 17. Receiver also going to use the same key, but the process is reverse. Here we are going to perform subtraction operation. Our key is 3. 10 minus 3 will get 7. 7 minus 3 4. 14 minus 3 11. 14 minus 3 11. 17 minus 3 14. If we convert these numbers into characters, we will get our plain text. 7 represents H, 4 represents E, 11 represents L, 11 represents L, and 14 represents O. In this way, encryption and decryption is performed by using Cipher Cipher. This is ASCII code table. Our program is developed based on this ASCII codes. If you are not using this ASCII codes, you will get ciphertext as special symbols, numbers, or characters. To make the ciphertext within the characters, I use this ASCII codes. So ASCII code numbers are start from 65 to 90. It will represent uppercase letters, and 97 to 122 it will represent lowercase letters. We'll see the same example with ASCII codes. Encryption is performed by sender and sender plain text is same hello HELLO. ASCII code numbers for this hello is 72, 69, 76, 76 and 79. We are using same key, that is 3. We are going to add this key with ASCII code numbers. It will generate new ASCII codes. 72 plus 3 75, 69 plus 3 72, 76 plus 3 79, 76 plus 3 79, 79 plus 3 82. If we convert these ASCII codes into characters, it will generate KHOOR. This ciphertext is forwarded to receiver. Receiver going to perform decryption. So ciphertext is KHOOR and its ASCII code numbers are 75, 72, 79, 79 and 82. We are using same key 3 and we are performing subtraction operation. After performing subtraction operation, it will generate use ASCII codes 72, 69, 76, 76 and 79. If we convert ASCII codes into characters, it will generate HELL. Assume this is one network. This particular system is our sender with an IP address 192.168.1.25 and the sender system is using port number 13154. The laptop is our receiver. IP address of receiver is 10.10.10.10.10 and port number is 13154. To communicate, the sender will add this IP address and port number in the packet so that the connection is established. See, color is changed. Now the connection is established. Yes, receiver also got confirmation from the sender. Now sender will select a message and select a key, encrypt the message by using Caesar cipher technique. It will generate ciphertext. That ciphertext will be forwarded in the network. If anyone try to capture the message in the middle, they will get the ciphertext as KHOOR. They are unable to decrypt this ciphertext until they find the key. So the ciphertext is delivered to our destination. Destination also uses the same key. With the same key, it will be decrypted and the destination system will generate plain text message as. This is encryption logic written in sender program. This logic is specially designed for lowercase letter conversion. CH is our plain text message character. This CH is added with key and the result again stored into CH. If the result is greater than Z, means if the ciphertext out of alphabets from A to Z will try to convert that ciphertext within the lowercase alphabets by using this logic, that is CH equals CH minus Z plus A minus 1. In the same way, I written logic for uppercase letters also. Same logic, just the case is changed, uppercase letters. Coming to decryption, decryption is exactly reverse to encryption. So we are applying the same concept here. Here CH is our ciphertext character. Ciphertext character is subtracted with key and the result is stored into CH. If the ciphertext is out of small alphabets, we'll try to make the ciphertext within the small alphabet by using this logic. That is CH equals to CH plus Z minus A plus 1. This logic is for lowercase letter. And this logic is for uppercase letter. I already told, just case is changed. It is uppercase letters logic. Now we'll see how to execute the program. We have two different programs. One is sender program, another one is receiver program. These two programs are executed in two different computers. One computer acts as sender, another computer is act as receiver. Within these two systems, encrypted messages are exchanged and the receiver system is going to decrypt the message. But as you are staying in home, you are unable to execute the program in two different computers. That's why I am explaining the program execution in a single system by using two different terminals. To execute the programs, open two different terminals, one terminal for sender and one terminal for receiver. First execute receiver program. Before going to execute the program, compile the program by using following command: cc space program name .c -o. -o will create our output file, or that output file is copied into a new file. New file name is cr. To execute the program, just call cr.exe. Now the receiver program is ready to receive the message from sender. Go to sender program. First compile sender program, cc space program name .c -o and new name, new file name. Call that new file name cs.exe. Here we are going to pass two arguments. One is IP address of receiver system and port number of receiver system 13154. Here I am using this 127.0.0.1 as receiver system because we are executing the program in the same system. That's why I am using loopback address. If you are executing this program into different system, you have to specify receiver system IP address here. And this is receiver system port number. Now the connection is created. Verify in the receiver window. Yes, connection from 127.0.0.1. Go to sender program. Give your plaintext message, that is hello, and our key is 3. It will encrypt the message KHOR and that KHOR is forwarded to receiver. Receiver got the message, that is KHOR ciphertext. To decrypt the ciphertext, receiver also uses the same key 3 and it will be decrypted. In this way, execute the program. Thank you.